We'll start by taking a look at the FileCounterForkJoinTask implementation. And this particular implementation, as we're going to see, uses the Java ForkJoin framework and Java 7 with just classic object-oriented techniques. There's no functional interfaces, there's no Lambda expressions, there's no method references, there's no Java streams. This is just a very simple way where we do some forking and joining, not unlike what you did for assignment number 1. So let's go ahead and take a look at that code. So here we are back in the IntelliJ project for the ForkJoin example, and let's take a look at FileCounterForkJoinTask. Now, the first thing you'll notice is that this extends the AbstractFileCounter class. So let's take a quick look at that. AbstractFileCounter is an abstract class, which means it has obligations that must be fulfilled by subclasses. And it extends recursive task parameterized with long, because that's what it's going to return, the number of bytes that it processes. It's got a couple of fields. It's got a file that we're working on, that we're analyzing. It's got an AtomicLong that keeps track of the number of documents, and an AtomicLong that keeps track of the number of folders. The reason we use AtomicLongs is because we're going to be incrementing and decrementing these things in different threads, and we don't want to have corruption of this mutable shared state. So we're going to protect it with AtomicLongs, which are super fast implementations that work very well to increment and decrement counters, as we're doing here. The constructor stashes away the file and then creates AtomicLongs with the value of 0. And then there's another constructor that takes the AtomicLong for document count and folder count and stashes them away. That gets used when we do recursive decomposition and recursive traversal. And then we have a couple of helper methods, document count, which returns the number of documents we've seen, and folder count, which returns the number of folders. So this is just here to kind of make everything else have less duplication of code. It's one of those good old-fashioned don't repeat yourself principle concepts. So let's take a look at the actual implementation. Here is one of the constructors. This constructor takes a file, calls up to the abstract file counter, passes the file up, that stashes it away. That's one constructor. That's really the entry point constructor. And then there's also this internal constructor. You notice I made it private. That's used in the implementation. And it takes the document count and the folder count, and it calls up to the superclass to initialize that stuff. We'll see how that gets used here in the compute method. Here is the compute method. This is what does all the work in this implementation. What it's going to do is it's going to return the size of the number of bytes of all the files reachable from this starting point. So first we're going to see if the file is the M file, which is what we were given. Is it a file, like a document, or is it a folder or a directory? And we can do that by asking it, are you a file? And if it says, yes, I'm a file, then we simply increment the document count or the file count by 1, and we return the length of the file in bytes. Because we're going to aggregate those things together to get a final count, starting at some root in a recursively structured hierarchy. If it's not a file, it must be a folder, so we increment the folder count. And then what we're going to do is we're going to make ourselves a list of ForkJoin tasks. This, again, is very similar to some stuff that you've been doing. And what we're then going to do is we're going to get the list of files associated with this folder. So if it's a folder, not a file, it's got a list of files. If it's a file, it's got a length. If it's not a file, if it's a folder, it's got a list of files. So for each file in the list of files, we're going to go ahead and make ourselves a new FileCounterForkJoinTask object, passing in each file one at a time, the current document count, the current folder count as AtomicLongs, and then we're going to fork this FileCounterForkJoinTask, which says, please arrange to run this thing in some thread in the ForkJoin pool that we're using. And then we're going to go ahead and add that to the forks list. So you'll notice a really cool thing here, and you might think about this when you modify your assignment 1 and when you do assignment 2. You don't have to create an object, fork the object, add the object to the list. You can kind of daisy chain them all together in this nice little cool way. And so we fork it, we create it, we fork it, we add it to the forks list. So everything gets forked. And then we're going to run this little piece of code. Now, I could have split this off into a helper method, probably should have, but I wanted to keep it simple. So now we're going to have a little accumulator, which is going to iterate through all the ForkJoin tasks that we've just forked off with the loop above. And for each task, we're going to join the result, which will give back a long, and we're going to keep a running sum. Remember that this join call does not block, but instead that thread pitches in to do computation until it finds that result. And when we're all done, we've got the sum of all the counts, and we return that as the value at this level of compute. So whatever this level is, that's what it's going to return. And of course, that's going to get aggregated here with the second half of this method, which is doing the joining. So we do a bunch of forking first, then we do a bunch of joining. Very canonical way, one of the canonical ways to do fork join pool. So that's the walkthrough of that implementation.